Dear students, thanks to all for watching my lecture. Today I am talking about moment of inertia. This is the very special part of Newtonian mechanics, physics first paper. Okay. Now, at first we discuss moment of inertia of a particle. This is our first duty to find out the moment of inertia of a particle. Actually, what is moment of inertia? Okay, when any kind of the object rotate around the axis, then the mass of the particle turn it into the moment of inertia. Okay, according to the definition of the moment of inertia, the product of mass that is rotate around the axis and square perpendicular distance between the rotational axis and the point of the mass is called moment of inertia. Now I am trying to clear you by the drawing a diagram. Okay, my dear students, suppose this is a particle. Here I am trying to show you this is the particle. Okay, this is the particle, this is the suppose this is a particle. The mass of the particle is m. Mass of the particle. My dear student, this is the mass of the particle. If this particle rotate around the axis, suppose the rotational axis is, this is the rotational axis. Okay, if this particle rotate around this axis, suppose the name of this axis is x prime. X prime is a rotational axis, and if this particle rotate around this axis, then this mass of the point mass of the object turn it into moment of inertia. Suppose the distance between the mass and the rotational axis is, this is x prime is a rotational axis, and perpendicular distance is r between the rotational axis and the point mass. The name of this axis is rotational axis. Rotational axis. My dear students, now we try to find out the moment of inertia of the particle. According to the definition of the moment of inertia, we represent moment of inertia by m. Moment of inertia. We represent moment of inertia by the symbol I. I is equal to product of mass. Product. Suppose this is the mass of the particle and a square perpendicular distance r. R square. Perpendicular distance of the rotational axis and the point of the mass. Okay, I represent the moment of inertia here. Here we see the equation to find out the moment of inertia. The mass m is the mass point mass that is already rotating around the axis. The rotational axis is x prime, and this is the rotational path. This is rotational path. If this point mass m rotate around this axis, then at first we product. Here we see product of mass and square perpendicular distance. R is the perpendicular distance. Always try to remember that here r is a distance and this distance is a perpendicular distance. Perpendicular distance. Perpendicular distance. distance from the rotational axis and the point of Mars. My dear student, try to understand. According to the definition of the moment of inertia is the product of mass and square perpendicular distance between the rotational axis and the point of the mass is called moment of inertia. Okay, this equation only find out moment of inertia in case of the point of the mass. Always try to understand this equation only valid for the point of mass, not a object. Okay, in case of a object, if we find out the moment of inertia, then at first we must find out the moment of inertia of a particle. Okay, now our duty is to find out the moment of inertia in case of an object. Okay, and as this equation is valid for only the particle. Okay, if suppose if this is an object, suppose this is the object, this is the object. Okay, irregular shape of the object. How can we find moment of inertia? If this object rotate around a axis, suppose the rotational axis is this is the rotational axis. Okay, this is the rotational axis. Suppose the rotational axis is x prime. Okay, if this object rotate around this axis, okay, then suppose the velocity, angular velocity of this object is this is rotational axis x prime, and this is the rotational path, and omega represent the angular uniform velocity. Omega is angular uniform velocity. Okay, the omega is represent the angular uniform velocity. My dear student, try to understand. We only just drive equations for find out moment of inertia in case of a particle. Okay, but as this is the object. Okay, this is an object. Okay, not a particle, object. Then how we can find out the moment of inertia of this object? This is very important for us. Okay, as we know every object made by particle, we can assume that this object made a lot amount of the particle. Suppose at first, as we know moment of in equation, the moment of inertia of a particle. So at first we point out some of the mass of this object. Suppose this is the point mass, the mass is m1, and this is the another point of mass is m2, and this is another point of mass m3, and this is another point of mass. Suppose this object made by a lot numbers of the point of the mass. Suppose the n number of the point of mass has here. With the help of these equations, moment of inertia of a particle I is equal to mr square. Our duty is to at first find out the mass of a particle, and then find out the distance, perpendicular distance between the rotational axis and the particle. Now we try to find out if this object rotate around the x prime axis, then the rotational path is omega for every particle m1, m2, m3 and mn. Every particle rotational path will be changed. Okay, suppose the rotational path of m1 object will be this is the perpendicular distance. Okay, in case of M2 object, this is the perpendicular distance, and in case of M3, this is the perpendicular distance. In case of Mn, this is the perpendicular distance. My dear student, our duty is to find out the distance. Okay, suppose the distance is, this distance is R1, and this distance is R2, and this distance is R3, and this distance is Rn. We just try to understand, if this particle rotate, then the circular path of this particle will be, this is the circular path of this object. Okay, and for this object, this is the circular path, and this object, by this way, every particle has different shape of the circular path. Okay, different shape of the circular path, and radius will be different for different particle. Okay, now our duty is to find out the moment of inertia m1 particle. Suppose the moment of inertia m1 particle is I1. Our equation is, at first we write m1 and perpendicular distance square, r square. This is the moment of inertia of m1 object. In case of the second particle, we can write m2 r2 square. In case of third particle, we can write m3 r3 square. Okay, by this way, as we assume this object made by a lot amount of the particles, so the number of particle is n, so we can write moment of inertia n particle. So mass, we can write mass, n number of particle mass m n, and perpendicular distance Rn square. Now our duty is to summation all the moment of inertia of the all particle, then we get the total moment of inertia. Okay, my dear student, if we summation moment of inertia of all the particle, then we get moment of inertia of an object. So we can write here moment of inertia of an object. So we can write moment of inertia, moment of inertia of an object. This is the special technique to find out the moment of inertia of an object with the help of the find out the equation of the moment of inertia of a particle. This is very important. Okay, so our duty is to summation moment of inertia of all the particles. So I is equal to, we can write I1 plus I2 plus I3 plus dot In. This is the equation for moment of inertia of an object. So we can write here the value of I1 is m1 r1 square plus m2 r2 square plus m3 r3 square dot plus mn rn square. This is the equation for find out the moment of inertia of an object. Okay, in case of the object, this equation will be valid, but this equation only valid for a particle, moment of inertia of a particle. Okay, this equation only represent moment of inertia of a particle, moment of inertia of a particle. Okay, I think all of you clearly understand actually how can we find out moment of inertia, any kind of the irregular shape of the object. Okay, If the shape of an object is not uniform, irregular shape, then this is the process for find out the moment of inertia. How we can find this equation? At first we try to find out the moment of inertia of a particle. We know every object made by a lot number of the particle. Because of that reason, our concept is we just divide an object a lot number of the particle, and at first we find out the moment of inertia of a particle. Every particle plays and different position from the rotational axis. We can see x prime is a rotational axis, and if this is the particle of an object, then the distance between the rotational axis of this particle is r1. But in case of the m2 particle, then the rotational the perpendicular distance between the rotational axis and the point mass is r2. Okay, so because of that reason, the rotational path of m1 object and rotational path of m2 object will be different. That means here has a lot number of the particle, and every single particle rotational path will be different, and distance perpendicular distance will be different from the rotational axis of between rotational axis and the point of the Mars. I think that all of you clearly understand, and this is the actual technique to find out the moment of inertia of an object. Okay, my dear student, now our duty is to write this equation mathematically in our mathematics. We can write this equation by a special notation. This special notation is summation. Okay, this is the symbol of the summation. Okay, when we use this symbol, then we at first we confirm the limit. Okay, suppose the lower limit is I and upper limit is n. Okay, our value of I is start from 1. Okay, now we write here m I r I. This is the special technique to represent moment of inertia of an object with the help of this equation. Now the value of I is set from 1 to n. So we can write here I is equal to 1, 2, 3, 4 dot n. Okay, if we put this equation value of I is 1, then we get first term, and if we put the value of I is equal to 2, then we get second term m2 r2 squared, and if we put the value of I3, then we get the third term. By this way, if we put the value of n, then we get the last term. Okay, so this is the special technique to find out the moment of inertia. Okay, my dear student, this is the special equation. This equation can represent moment of inertia of an irregular shape of an object. Okay, now we discuss a special things, radius of gyration. Now another topics, now we discuss another topics. The name of this topics is radius of gyration. My dear student, this is also very important. The radius of gyration. What is radius of gyration? My dear student, radius of gyration is nothing but this is also a special perpendicular distance between the rotational axis and the mass that is concentrate the center of the gravity of an object. Now we discuss. Okay, suppose this is the object. Suppose this is the object. This we know this object has a center of the gravity. Suppose the center of the gravity is m. Suppose m is the center of the gravity of this object. We know all the mass of this object concentrate on this point. Okay, suppose this is the point. Now we try to clear you. This is the point. Okay, this is the name of this point is center of the gravity. We know all the mass of this object concentrate on this point, and from the rotational axis, if this object rotate around this x prime axis centering, then here has a perpendicular distance between the object between the center of the gravity and the rotational axis. And suppose this is the perpendicular distance, and this special perpendicular distance noted by k, and this k represent the radius of the gyration. Now we clear by drawing another object. Okay, my dear student, suppose this is the object. Suppose this is the object. Okay, and this is the rotational axis. Okay, suppose the name of this rotational axis is x prime. Okay, x prime. Suppose this is the point, this is the center of the gravity, this is an object. Okay, object. We know, all of you we know all the mass of an object concentrate on this a particular point. Suppose the mass is m. The mass of the object concentrate on this particular point. Okay, if this object rotate around this axis, then here has a perpendicular distance between this point and the rotational axis. Suppose this perpendicular distance is this. Okay, and we denote by this perpendicular distance by k. Okay, by k, and this k is radius of gyration. I think all of you clearly understand. And with the help of this distance and this concentrate of the mass, we can easily find out moment of inertia. I is equal to m k square. That means if we find out moment of inertia with the help of the find out the equation of the moment of inertia in case of the point mass of the object, then this equation will be valid in case of the radius of the gyration. Why this equation will be valid? Because we know moment of inertia depends two things. One is, if we go our first equation, then we try to understand moment of inertia depends two things. One is point of the mass and a square perpendicular distance between the mass and of the object. Okay, if the perpendicular distance between the rotational axis and the point of the mass is increased, then the moment of inertia will be increased. If r decreased, then moment of inertia will be decreased. Okay, but mass is here constant. So here this distance is, I think this distance is the average distance. Okay, as we cannot find out an particle of an object has a lot number of the particle here, every particle has a different type of the distance. So if all the mass of the particle are concentrated on this point, then this distance k represent the average distance from this mass. Okay, so this distance is the radius of the gyration, and if we find out the moment of inertia by this equation, the equation and in our previous equation will be same. Suppose if we use this equation, that means I is equal to 1 to n mi n r I square, mi and ri square. So this equation and this equation, both two equation will be valid for this object. Why do both two equation will be valid? Now I am trying to discuss. Okay, this equation is the process this is the process for finding out the moment of inertia of an object. At first we try to find out the moment of inertia the particle. As this object made a lot number of the particles, so it is very difficult to find out the moment of inertia for every single particle. Okay, we just assume this object has a number of the particles. So if we find out equation of the moment of inertia of every single particle, then m1 r1 square plus m2 r2 square m3 r3 square. So it is very challenging for us. Okay, and if we summation all the particle moment of inertia of all the particle, then we get the moment of inertia of an object. But this is also a special process. If the moment of inertia of this object is I is equal to summation mi square, this is the equation, this is the process for finding out the moment of inertia of an object. And this is the another equation, this is the very simple equation, I is equal to mk square. Here try to understand, m means the total mass of the object and k means a special distance. What is the special distance? This special distance is k. Every object has a special distance from the rotational axis and a special point. The name of this special point is the center of the gravity. Center of the gravity. Center of the gravity. Try to understand, this distance is the actually average distance between the rotational axis and this point. Okay, as we assume all the mass of an object concentrate on this particular point, so every object, every rotational object has this special distance from the rotational axis, and this special distance is called radius of gyration. This is called radius of gyration. Okay, and if we find out the moment of inertia, then we at first we put the mass and square distance k square. This is the process. I think that all of you clearly understand actually how we can find out moment of inertia of a single point of the mass and irregular shape of the object. This is the process. Okay, my dear student, I think that all will be clearly understand. If you face to understand any kind of the point, then please write down the comment or write down comment on the comment sections. I am trying to repeat this part again. Thanks to all.